Hello everyone, my name is MD ZIHADUL RATUL. I am a student of University of Malaysia Kelantan. Currently I am in FSTK faculty and my metric number is S23A0095. This video represents my individual projects for the JIE 43303 Natural Language Processing or NLP. The presentation will be divided into two parts. At first, I will explain the project using presentation slides, and after that I will demonstrate the live working system including model training and deployment. The title for my project is Mental Health Text Classification using NLP. The project focuses on applying NLP to automatically classify mental health related text data. The main goal is to learn how machine learning and deep learning tools can help detect mental health indicators from written text in a scalable and automated way. Alright, mental health disorders affect hundreds of million people worldwide. However, early detection remains difficult due to social stigma and the limited availability of mental health professionals. At the same time, people increasingly express emotions through social media and online forums and chat messages. Manually analyzing such a massive volume of text is not scalable, which motivates the need for automated NLP-based solutions. Mental health text is challenging to analyze automatically. First, emotional expressions are often subtle and context dependent. Second, language can be ambiguous and culturally influenced. Another major challenge is class imbalance, where natural text dominates the datasets while mental health related classes appear less frequently. These challenges make traditional NLP methods insufficient, motivating the use of more advanced models. Now let's move to the project objectives. This project have total 5 main objectives. First, to analyze and pre-process mental health text data. Second, to build an interpretable baseline model using TF, IDF and logistic regression. Third, to experiment with a transformer-based model, DistilBERT. Fourth, to evaluate and compare both models using standard metrics. Finally, to deploy the model using a web-based application for real-time prediction. The dataset used in this project was obtained from Kaggle and contains multi-class mental health text. The dataset reflects real-world class imbalance, which increases modeling difficulty but improves realism. The main tools was included Python, scikit-learn, TensorFlow, Hugging Face transformers, Google Colab for training and Flask for deployment. The workflow begins with data loading and pre-processing. Next, TF-IDF feature extraction is applied, followed by logistic regression training as the baseline model. In parallel, a DistilBERT transformer model is fine-tuned to capture deeper contextual meaning. Finally, the trained baseline model is deployed using a Flask web application. Two models were used in this project. The baseline model combines TF-IDF logistic regression, which is efficient, interpretable, and computationally lightweight. The transformer model DistilBERT provides context-aware embeddings and performs better on subtle emotional expressions. Models were evaluated using accuracy, precision, recall, F1 score, and confusion metrics. Result shows that DistilBERT outperforms the baseline, especially in recall for majority mental health classes. However, this improvement comes with higher computational cost, making the baseline model suitable for deployment. The final system is deployed as a Flask-based web application that supports real-time prediction and confidence visualization. Next, I will demonstrate the model training process and the live working system. To show the live view, we need to come to our window first. So here is my Google Colab. So before deployment, all model training and experimentation were conducted using Google Colab. Here I perform dataset loading, pre-processing, TF-IDF feature extraction, model training, evaluation and saving of trained models. This notebook documents the entire experimental pipeline, ensuring reproducibility. Then come to our actual project folder. So here is my project folder. So now I will open command prompt and type python app.py. So after training, the saved model artifacts are used by this Flask application. Running this command starts the local web server. So next we need to open a browser and go to this link. This is a local host. Okay, now this is the deployed Flask web application running locally. So you can see if I want to do an action, I mean if I want to type a sentence in here, like I want to type I feel very tired lately and nothing seems enjoyable anymore. Okay, so after typing this sentence, if I click predict, okay, so after clicking predict, the system performs pre-processing, vectorization and classification in real time. So you can see the predicted class is shown here. So below it we see an animated confidence meter indicating the model's confidence. We can see here the depression level, the suicidal level and the normal level. So basically class-wise probabilities were actually displayed and allowing transparent interpretation of these predictions. So also the color-coded outputs enhance clarity and experiences. In conclusion, this project demonstrates how NLP techniques can be effectively applied to mental health classification. So transformers models provide higher accuracy, while baseline models remain valuable for efficient and interpretable deployment. One more thing, this project is strictly for academic and research purposes, and it is not a medical diagnostic tool. So that's all from my side. Thank you for watching.